Welcome back to Momentum. Today we're going to look at collisions. In any collision, momentum is conserved. That's a key element in this section. Momentum is conserved. That means momentum before equals the momentum after. And this is before the collision and after the collision. Now, this doesn't matter whether it's an elastic collision, inelastic, or perfectly inelastic collision. Just remember that in an elastic collision, kinetic energy is conserved, but we're not going to deal with that part. We're going to just look at inelastic collisions and perfectly inelastic collisions. Just remember this. Now, here's the way to do it. Give each one, look at what you got, and tell that each one has collisions. So you can see, if you see the word collisions or hits, momentum is conserved. So how many objects do we have? We have a 3 kilogram ball, so that has momentum, and we have a 5 kilogram ball, which has momentum. That's our MV. That's before the collision. I'm going to spread this out so we can move some numbers here. Now after the collision, so plus MV. So you can see if you have two objects before the collision, you're going to have two terms to show your two objects afterwards. If we need to, we combine our math units. Okay, so let's see. We're going to call that, we have a 3 kilogram ball going at 3 meters per second. Okay, now this will be for our 5 kilogram ball. It's going at 2.5 meters per second. Okay, there's the 4. Now we're going to call this is the 3 kilogram ball. That's going to be the larger. Now in some books they may have you M1 and M2, but we're just going to let you figure this out, or let you kind of remember this yourself. It says that the larger balls, well, I know I had a 3 and a 5 here, and it said the larger ball was traveling at 2.8 meters per second, so it says what's the velocity of the smaller ball. So there's our unknown, and V is in meters per, if I can write, meters per second. Okay, let's look at the next one. I have a runner and another runner. So that means I have two objects. So each one will have momentum. So if you notice, if I had two objects before, I'm going to have two afterwards. Now since we have this, and let's see, we have a 100 kilogram runner. So make sure your masses are the same. And it's traveling at 2.7 meters per second. And this is a 90 kilogram runner. This is a 90 over here. So you notice the masses are the same. And it's traveling at 3.7 in the opposite direction. So velocity does have direction. So you notice it says opposite. So if this is a positive, this has to be negative. And what do we have left? It says what is the combined velocity. So I have these here. We have two terms with the same variable. Well, think of what you would do in your math class. You're going to solve for V, and V is in meters per second. Okay, we have a rail car, okay, hitting another rail car. So I got MV plus MV equals, we keep our same unit, our same numbers on the same side of terms, that is. So I got okay, traveling at 3.7. Now the second one, yep, is it stationary? What does stationary means? 0. And so we have our 130,000, and then the 150,000, and says, since we don't have that, there's our unknown. V is in meters per second. Okay, here's another one. I got 2 balls. Okay, MV plus MV, okay. So if I have 2 terms here, I'm going to, it does help if we put the equal sign, MV plus MV. So the 45 is rolling at 5.8. So make sure if you want to, you can go on and put that for one of the masses on the other side. And then we have a 35 kilogram ball. So the other mass is 35. And then it's traveling in the opposite direction. Okay, so it's rolling at 4.7 in the opposite direction. So there's a negative there. It says after the collision the ball is moving. So here's our larger ball. So that's negative 4.8. And there's what we're looking for. And there's our V is in meters per second. And you notice we have a lot of collisions. You just use the conservation momentum and you can just solve for your unknown. Okay, for you hunters out there, okay, I got a shotgun and a slug. Okay, so I have 2 objects, and as before, I got MV plus MV, that's before, equals MV plus MV. So you notice I've got, do this, let's get our masses in. 0.0065 for the second mass, 0.0065, and it says this is, okay, just think it fires, so that's afterwards. So that's 400. It says, what is the recoil? In other words, I'm looking for the V. Now you're probably thinking, what is my V's at the beginning? Now just think, at the beginning, it's stationary. So I'm going to put in here just for y'all to help you out. So it's stationary. So if it's not moving, the velocity is 0, therefore no momentum. So V is equal in meters per second. I have one more. You notice I've got the shotgun, a person, and the slug. So I have 3 of them. So I'm just going to put 3 here. Make sure I have the same number of terms on each side. Okay, so I have 3. And this is 75. And this is 0.0065. Okay, and let's put in our velocities. Well, it says, what is the recoil velocity of the system? Well, the slug is going at 400. Now at the beginning, before anything happened, everything was stationary, right? So that made that 0, this 0, so there was no momentum in the system before. And we want to know the recoil of the system. We want to know the person and the shotgun. So V is in meters per second. Hope you learned a little bit. If you have any questions, feel free to contact me.